In this example, we're going to be solving for velocity. So here we have a cyclist traveling 3.50 meters per second south and accelerating at 1.12 meters per second squared south. What is the velocity of the cyclist after they've traveled 32.5 meters south? So everything in this instance is in the same direction, which is kind of nice. And since the cyclist begins traveling 3.5 meters per second south and accelerates at 1.12 meters per second squared south, we know that he's probably going to be going faster at the end of his journey or her journey. I used it in this question for some reason. So in this case, we've got a north and a south motion. So let's say this is south and that's north. Initially, some point over here, we've got our little cyclist traveling at an initial velocity of 3.50 meters per second south. At some point later, there's our really long bicycle, probably traveling at some larger velocity south, but we don't know what it is yet. Throughout this entire motion, the cyclist is accelerating south at 1.12 meters per second squared. And we also know that this entire motion, there's a displacement, 32.5 meters, also south. So there's all of our information. Now we get to choose what's positive and what's negative. In this case, since every single direction is south, I'm going to make my life a lot easier and say south is positive. So just summarizing all of the variables that I know V1 is 3.50 meters per second in the positive direction. V2, I don't know yet. Acceleration is 1.12 meters per second squared in the positive direction. And displacement is 32.5 meters in the positive direction as well. So now I take a look at the variables. I want V2, but I know V1, acceleration, and displacement. I don't know the time, but I don't really care in this question. So I'm going to go back to that table at the very beginning of the note, and we're going to scroll down and look for a kinematics equation that doesn't include time, but includes all of the other variables. And again, we arrive at the one at the bottom. We've used this one once already today, but we're going to come back to it. But this time we're going to solve for V2. So back to the question. Here's the equation that I want to use. V2 squared equals V1 squared plus 2 times acceleration times displacement. So now we can substitute some things into this equation. Handily, it's already rearranged for us because we actually want to solve for V2. So 3.50 squared plus 2 times the acceleration, 1.12, times the displacement, 32.5. Simplifying this one little bit at a time, because yes, we do want to keep track of significant figures. 3.5 squared is 12.25, but I want to round to 3 significant figures in the end. 2 times 1.12 times 32.5 is 72.8, again to 3 significant figures. So V2 squared is both of those numbers added together, 85.05. I'm going to round to the 10th place because if you look, the least precise decimal place for both of those numbers is the 10th place. The last step is to take the square root of both sides of that equation. The square root of that number is 9.2223 meters per second. Since I just took the square root of a number with 3 significant figures, I better round to 3 significant figures in the end as well. So my final answer is, therefore, the cyclist is traveling at 9.22 meters per second south. We go back to our original question. That sounds about right. They started 3.5 meters per second south. They're accelerating in that direction, so it makes sense that their velocity is going to be larger in the southward direction.